Let's take this opportunity to observe the potential of harnessing the pressure gradient flow or movement of fluids, from an area of high pressure to an area of low pressure. In particular, let's focus on the gradient energy that might be harvested, salvaged or recovered in the form of low-pressure zone forces. The Recovery 2.0 system is an innovative approach to manage the treatment of residual waste materials, in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy by using thermal reduction. Within the Recovery 2.0 process, we have focused a great deal of effort on energy recovery in an effort to manage the energy continuum while attempting to maintain a balance or equilibrium with our environment. The opportunity for gradient energy harvesting may be created by manipulating low-pressure zones to invoke the movement of fluids, either the movement of gases or the movement of liquids, or the potential interaction between both gases and liquids. Several fundamentals drive the fluid dynamics of low-pressure forces, including the Bernoulli principles, the Venturi, Magnus and Coanda effects, which result in a siphon or vacuum draw phenomena. There are several actions, mechanisms and devices that may be designed to create or control low-pressure zone forces. Today we will focus on the four main areas that we attempt to utilize within the Recovery 2.0 system to harness low-pressure gradients. The first low-pressure zone force that we take advantage of is the thermal contraction of the cooling of a gas. This is the underlying driving force of all heat engines, including liquid piston and Stirling engines. The second reaction is the rapid volumetric ratio reduction, or phase change effect, such as occurs from the conversion of steam into liquid water. The third low-pressure gradient is a forced kinetic piston displacement action, which is driven by devices such as a bellows, a piston or a syringe plunger. The vacuum effect resulting from a continuous fluid flow creates the fourth low-pressure gradient, which is a draw known as the Venturi effect. Continuous fluid flows also create a lift and drag effect. These four low-pressure zone forces may be in the form of a continuous flow, an intermittent flow or as oscillating fluid flows, and may include just gas, just liquid or a combination of both fluids. The challenge then remains to convert the fluid motion into a harvested form of energy, such as electricity. The most common conversion methods include either electromagnetic induction, electrostatic induction, or the piezoelectric effect, which may largely be determined by the appropriate velocity or torque. Harvesting salvaged energy in the form of low-pressure gradients is a key objective within the Recovery 2.0 system. We intend to discuss additional facets of the energy recovery sector at some point in the future. Until then, please feel free to contact us at your convenience. Recovery 2.0 is a project developed by Waste.net, in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us today at www.waste.net.